Okay, this is 11.3. This is finding the area of regular polygons. Okay, or finding the area of polygons. Here is the formula we'll be using. A equals 1/2 times A times P. What these letters stand for is, I'll write this up here, area is going to be equal to 1/2 times the apothem. There's a new word for us that we will learn. Apothem times P perimeter. Okay. Or this one, which is area, equals 1/2 times the apothem times n, which is the side length. So n is side length, so I'll write that. Times the side length times the sides. Okay, and that's where we get perimeter. Okay, so area is 1/2 the apothem times the perimeter, or area is 1/2 the apothem times one side length times the number of sides, which is essentially the perimeter. Okay? Now, probably asking me, what the heck is an apothem? Here we go. Every polygon can be put inside a circle, with each vertice touching that circle. That's probably the most important part of this lesson. The distance from the center to any side of the polygon is called the apothem. Okay, right here. Okay, that's an apothem. Okay, it creates this right angle with the side length. It's the distance from the center to that side. We still have a radius, right? The radius is from any vertice or that circle to the center. Okay, that's going to be important for later. Okay. Okay. So I want to try this. Remember, area is equal to 1/2 A times the perimeter. So 1/2 the apothem times the perimeter. Regular pentagon, how many sides does a pentagon have? Pentagon is 5 sides. Okay, sorry, we're on number 4. That's where we're starting. We're not doing number 3. We're doing number 5 or 4. A regular pentagon has 5 sides, and each side length is 6 meters. Each side length is 6 meters. What's the perimeter? We know the perimeter then, right? If there's 5 sides and each side is 6 meters, well, the perimeter was 30. 5 times 6, 30. The apothem is approximately 4.13. Find the area. Let's just plug this in. A is going to be equal to 1/2 the apothem, which is 4.13, times the perimeter, 30. And that 13 looks like a B. I'll fix that. Okay. And then go on your calculator. That's where we're going to type in 4.13 times 30 times 0.5. Okay. Oh, see, I want to redo this. Times 30. Oh, wait, that will be right. Divided by 2. Okay, so I just want to make sure. 61.95. 61.95 meters squared. Okay. All right. Moving on. Here's some definitions. Okay, the center of a regular polygon. The center, it's the center and the radius of its circumscribed circle. Okay, circumscribed circle, that just means the circle around it. The circle around that polygon. Okay. The radius of a regular polygon is the same thing. So, I can draw this for an example. Let's just take a square. Okay, there's a square. My circle is going to go, obviously this isn't perfect. It's just like this, okay? There's my center. There's my radius, okay? And my center. The radius goes from the vertex to the center of the shape. Okay, the apothem, I'm not going to write a definition, I'm just going to draw it. The apothem goes from the center to a side length. Okay, it's going to be a little shorter than the radius. And then the central angle of a regular polygon. So, I'm going to redraw a circle or something else, redraw a shape. Okay, I'm going to draw a pentagon. Actually, no, a hexagon. Okay, there's a hexagon. Here's my circle around it. Okay, something like that. The central angle, okay, we'll think center. The central angle goes from the center to two consecutive vertices of our shape. And it's this angle here. How do I solve for that angle? We take 360 divided by the number of sides. Okay, so in this case, we have one side, two side, three side, four side, five side, six side. It's a hexagon. Okay, so 360 divided by 6. That's going to give me the central angle, which is 60 degrees. Okay. Alrighty. Moving on. The areas of rhombuses or kites, it's a little different. Here we use these rules. Okay, D1 is this one right here. D2 is this diagonal here. Whole diagonal. And here's our formula. We take those diagonals, multiply them together, and then multiply by half. In a kite, here's D1, here's D2, multiply them together, divide by 2. Okay? We can try that out right now. I think those are our first example problems. Yep, right here. Okay, so we want to take this first diagonal, which is 14, multiply it by 10 times 10, which is 100. Oh, sorry, 20, not 100. Or yeah, sorry. Let me go back up. What is our formula? Yeah, we multiply them together. Yep, so that diagonal is 14, this diagonal is 20. Multiply multiply it by 2, okay, or 7 times 10, which is 70. Okay, my apologies. Not 70. Do it in my calculator. It's more trustworthy. 14 times 20 divided by 2 gets us 140. Inches squared. Okay, let's try it on this one. We have 5 and 3, which is 8, times our other diagonal, which is 2 and 2, which is 4, and divided by 2, which is 32, divided by 2, which is equal to 16 centimeters squared. Okay. Now, getting into more challenging problems here. Find the measure of the central angle of a regular polygon with 8 sides. Okay, so 8 sides. We have 1, 2, 3, 4, 5, 6, 7, 8, something like that. We want to find this angle here. How do we do that? Well, take one full circle, it's 360 degrees. So first going to take 360 and divide it by 8. It's equal to 45. Okay. Next one, number 4. The central angles of a regular polygon are 40 angles. How many sides does the polygon have? Okay, so we know that the central angle is going to be equal to 40 degrees. We want to know how many sides it has. Well, in our formula, 360 divided by the number of sides, we'll call it x. Solve for x. Multiply by x on both sides. We're left with 360 is equal to 40 times x. How do I solve for x? Divide by 40. We should get 9. 9. So 9 sides. And number 5. A regular pentagon has a radius of 4 inches and side length of 3 inches. Find the apothem of the pentagon. Okay. Draw these. It'll only help. Okay, there's my somewhat pentagon. Doesn't have to be perfect. There's my circle. Again, doesn't have to be perfect. Let's see. There's no regular pentagon inscribed in a circle. It has a radius of 4 inches. Okay, so the radius on my center is 4 inches. The side lengths are 3 inches. So right there is 3 inches. Find the apothem. And my apothem will cut that side in half. And how do I find x? Well, I'll act like to zoom in on that triangle here. Okay, here's 4 inches. Here's my apothem x. And here's my side length of 3 inches. Okay, I just zoomed in on that triangle with my apothem, radius, and side length. This is 90 degrees, which means this side length here is equal to this side length here, which means this is 1.5. Now, what do I have? I have a right triangle. And I can now perform the Pythagorean theorem to find the radius. Or my hypothesis, sorry. Okay, I can take 1.5 squared plus x squared is going to be equal to my hypotenuse squared. And solve. I'm going to get 16 on the right side. I'm going to be subtracting that. Actually, I'll do 1.5 squared first. And I'll get 2.25, so I'm going to subtract 16 from 2.25. There we go. My 13.75 equals x squared. Solve for x, I have to take the square root. And I get 3.7. So the apothem is about 3.7 inches. Okay, now find the area. The area is 1/2 times the apothem, which is 3.7, times the perimeter. Well, if each side length is 3 inches, that means this is 3 inches, this is 3 inches. All right, there's 5 sides. It's going to be 15. Calculator. 3.7 times 15 times 0.5. 27.75 inches squared. This next one. Find, or a regular hexagon has an apothem of 10 inches. Find the radius of the hexagon and the side length of one side. Okay, this one you absolutely should draw. It's a hexagon, so it has 6 sides. This one is tricky. This is a tough problem because it uses information from the past. Let's see, what do we know? It has an apothem of 10 units. Just 10. What do we want to find? We want to find the radius and the side length. Call it y. Okay? That's 2 variables, not 2 unknown variables. So, this is digging deep. What do we need to know to solve for one of those? Well, we need to either have 2 side lengths in order to solve for a third, or we need to have an angle and a side length. Okay, and that's my question. Can we find this angle here? The answer is yes, right? That's the interior, the central angle. So we're going to take 360 divided by the number of sides, which is 6. Should get 60. Okay, so this angle here is 60 degrees. Which means half of that, because the apothem cuts it in half, is 30 degrees. Okay? Now, how can I find x? Well, I can take the cosine of 30 degrees and set that equal to adjacent, which is 10, over the hypotenuse, x. I'm working with this triangle here. Now solve for x. Multiply by x on both sides. So we're left with x times the cosine of 30 equals 10. Divide by the cosine of 30. 10 divided by the cosine of 30 is 11.5. And 11.5. So the radius is equal to 11.5. How do I find the side length? Well, you can do two things. If x is 11.5, okay, you could do sine, cosine, or you can just do the Pythagorean theorem. Where this side here will be y. Okay, so we want to solve for y. Well, we know that 10 squared plus y squared is going to equal 11.5 squared. So I'm going to take 11.5 and square it. I'm going to subtract 10 squared, which is 100. And I'm going to take the square root of 32.25. Okay, and that'll be what y equals. Y equals 5.7. Okay, but we want to find a side length, which means we want to find that whole side, which means we have to multiply the answer by 2. And that'll get us a side length, 11.4. Good. And finally, find the area. Well, the area is equal to 1/2 times the apothem, which is 10, times the perimeter. Well, we know that the side length is 11.4, and there's 6 sides, so we're going to multiply this by 6, which is 68.1. And that's how we find our area. That is a tough problem. Should get 340.7 units squared. Tough problem.